Okay. This division strategy is called partial quotients. It is very similar to multiplying up, um, but instead of multiplying up, we will subtract down. Or using addition, we will use subtraction. And we use the little division house or hook. I like to call it. I don't know the name of it, but that's what I use. That's what we will use in these problems. We will be a bit more organized just because we have to keep everything under the house. Um, One thing that we do instead of just leaving it open here, we will draw a huge line down the middle, or down the end as well. Keep everything organized so we know what to subtract by, know what to add by a little bit. Um, so yeah. If we have the same expression as I used in the multiplying up video, which was 550 divided by 15, we will organize it this way. We'll have 15 on the outside because that is what's going into 550. You can't put 550 into 15. Have to do it by the smaller number. Then we draw the line down as far as we can go. And then I'm going to do the same factors that I multiplied by. So I'm going to do 15 times 10, and I'm going to add it on out here so we know that we have 15. And then 15 times 10 at the 0, 15 times 1 is 150. Now I subtract and I have 400. I most definitely can add 150 back into 400 to get, and we subtract, and I have 250. And I can add 150 into 250. So we have 150 minus to get 100. Yeah. And then I cannot add 150 into 100. So I will have to make smaller, multiply by a smaller factor. So let's do 5 like I did in the other video. And then I will get 75 because 15 times 5 equals 75. And then subtract 100 from 75 to get 25. I most definitely can add 15 into 25. I'm going to do by 1. This one can be trial and error as well, or this strategy can be trial and error as well. You just have to make sure we don't make any negatives. So if we make a negative, that tells you you went over and you don't want to go over. You want to be able to add the number that's on the outside, the factor that's on the outside, into this, into what we're dividing into. And then here, and so, and down, if we're able to go down anymore. We just want to make sure we get that evenly in. Even if there is a remainder, you don't want to have any negatives. So 15 times 1, and then we get 10 left. And this one is a bit more organized than multiplying up. So we know that this will automatically be our remainder because we cannot add 15 into 10. We just can't do it. So this is what we have left. We bring this up and over and we plop it right there. We could write R, stating that that's a remainder of 10. Now we can go through and count what we have on the outside here. Whatever we have on the outside, we add that up and that will be our answer. So we have 10, 20, 30, 35, 36. So our answer is 36, remainder 10. 36, remainder 10. Let's try. Also, another tip to note that when we are doing partial quotients, we do want to subtract down as many times as we can until we get to 0, if we are able to get to 0. In 550 divided by 15, we cannot get down to 0. That's why we have the remainder of 10. So let's try another problem. Let's do 120 divided by 3. And we will separate it out. 3 on the outside. And then 120. What can go into 120? Let's do 10. That's 30. So we'll put the 10 on the outside, and then we know we multiply here, we multiply back. So 3 times 10 is 30. And then we get 0, 12 minus 3, 90. We get 90. We can most definitely add 30 into 90. So let's add that in there. Multiply that. 90 minus 30 equals 60. Most definitely can add 30 into 60. So now we have 60 minus 30, and that equals 30. And we 100% can subtract 30 from 30. So let's multiply 3 times 10 again. And now we have a remainder of 0. There's no remainder. We got down to 0. What is ideal? And now all we do is count up what we have on the outside here. And that'll be our answer. So we have 10, 20, 30, 40. And our answer is 40. So 120 divided by 3 equals 40.